Hello everyone. In this video I'm going to go through some basics about the periodic table, what it is, how it's laid out, and why we ultimately have it. Now as you can see, this table is full of little squares with lots of different names in. These names represent all the elements that we have. Elements are chemicals that consist of one type of atom only. You can see there's so many that this table helps us to nicely arrange them. But more than that, more than just listing these elements, it actually helps to group these elements with similar properties. So the periodic table actually puts elements with similar properties together. And as you can imagine, that's incredibly useful for chemists to work from. So let's take this one at the top, for example, this box, and explain what we've got. So we've got the name of the element here given. So in this box, we're looking at zinc. You'll notice that it has the letter Zn above that. So we've got what's called chemical symbols or atomic symbols, and each one is given each element is given its own symbol. Some of them are a bit more clear cut. So if we take this one, if I highlight in red, hydrogen here is given the symbol H. If we look at carbon over here, we're given letter C, whereas lead, if we look at lead here, Pb, a bit more unusual. I have done a separate video on actually where these names originate from. So if you are interested in knowing why we use, for example, the letters Pb for lead, check out the video called Chemical Elements, What's in a Name? Because a lot of these names have Greek or Latin origin, really interesting origins. So we've got the name of the element in the box, we've got the symbol, the chemical symbol that it represents, but we've also got a number. Now this box here at the top has what's called an atomic number. The atomic number gives you the number of protons. So we'll just make a note of that. So the atomic number gives you the number of protons. And in a separate video, again, I've explained about protons, neutrons, and electrons. Now, as well as giving you the number of protons, it conveniently gives you the number of electrons because we have the same number of protons and electrons in these atoms. So the atomic number tells you the number of protons and electrons. Now, certain periodic table versions of the periodic table either give you all the information or omit certain bits. There is another number that you would find in these boxes, and that's called the mass number. And the mass number would tell you the total number of protons and neutrons. Neutrons being in the nucleus of the atom. So if you wanted to work out how many neutrons you have, you simply take the mass number, which is the number of protons and neutrons. You subtract away the atomic number, which would be the number of protons, and that would give you the number of neutrons remaining. In this particular periodic table that I've got for this video, it's a bit of a more simplistic version, but so we would have the mass number as well. But what we've got here are atomic numbers. But we're still able to explain some of these basic principles of the periodic table. So we've got the atomic number, we've mentioned the mass number, we've got the atomic symbol, and we've got the name of the element. Now the periodic table, as I said, is laid out so that elements with similar properties are together and they actually form columns. So these vertical groups, if you like, so these vertical columns, they're called groups, and we sometimes use Roman numerals to number or name them. So if you see a periodic table with Roman numerals above, then that's referring to these vertical columns or groups. And all of the elements in a group have the same number of electrons in their outer shell. So again, I've done a video on electron shells, and we've said that ideally atoms want to have full outer shells. When they don't, or when they react and gain and lose electrons, they become ions. So we're looking at the outermost shell or energy level, and elements in the same group, that's the same vertical column, have the same number of electrons in their outer shell. And this explains why elements in the same group have these similar properties. So if you know the properties of one, for example, if you take lithium here, if you know the properties of lithium, then if we look down that group and take this one quite randomly here with atomic number 37, rubidium, we know that they're likely to have the same chemical properties, they're likely to react in the same manner. They're actually known as group 1 elements. Those two that I've circled there, they're all metals. They react with water and form alkaline solutions, and hydrogen gas comes off. They also react with oxygen to form oxides, so sodium and oxygen react together to form sodium oxide, rubidium oxide, etc. The elements in this last column, just where I put an asterisk, and we'll number them in just a moment, they all have 8 electrons in their outer shell. And 8 is considered a full number. So they've got a full number of electrons in their outer shell, a full energy level. And what that means is that they are unreactive. So they are unreactive and they are stable. So they're known as the noble gases. So this last column, in fact, we'll make a little note here. These are the noble gases in this column. They have a stable full outer shell, the exception being helium here. Helium has 2 in its outer shell, it's just positioned there in the periodic table, but neon, argon, krypton, xenon, radon, ununtium, these all have a full outer shell. They're stable and unreactive. So let's just put in place the names of these groups. So this would be group 1 here. We've got group 2. This one is group 3. We have group 4 here. Group 5. Group 6. Group 7. And this one, where I've drawn the asterisks, is called group 0, our noble gases. And we can actually separate the periodic table out even more into its individual properties. So for example, if I highlight these 2 groups here just in red, then these are known as our reactive metals. So each section of the periodic table represents a different proportion of elements. So these are what are known as our reactive metals. So we can put them in place. If we were to highlight, and let's highlight in another colour, so we'll use different colours to represent all of these. This, in fact, we'll make that a little bit thicker as well, just to make that a little bit more obvious. If we were to highlight this region of the periodic table, up to that red line, in fact, we'll just draw that in for completeness sake. So this in yellowy orange, that area there comprises of our transition metals. So we find our transition metals in this region here. Other metals we can put in place, but I think it's important to put in a particular line before we do that. And this line goes just here. Now it seems quite unusual the way that it's staggered, but this line represents a division between metals and non-metals. So if we were to put in place this group of the periodic table, so this group that I've just highlighted in green here, that region of the periodic table represents our other metals. So we can just call these other metals. So we can see a big proportion of this periodic table is made up of metals. We've got reactive metals, transition metals, and our other metals. If I were to highlight, again, we'll just make it a bit more obvious, this portion of the periodic table here in blue. So I won't necessarily draw in the other blue line, but this region going from this black line separating the metal and non-metals to this blue line, so this whole portion here containing boron, carbon, nitrogen, oxygen, sulfur, bromine, iodine, this whole region here, that represents a region of non-metals. So this is the region of non-metals, which leaves us with a final column. And this final column, just for completeness sake, is this one here. And this one here, as we've already alluded to before, this is ultimately what we called our noble gases. So you can see our periodic table is made up of transition metals, reactive metals and others. We've got a region of non-metals and we've got our noble gases. We've got elements with similar properties grouped together in groups, so vertical columns are called groups. They have, in those groups, elements with similar chemical properties but ultimately the same number of electrons in the outer shell, so you can predict how they would react with certain substances. Each box in the periodic table contains a name, the name of the element, an atomic symbol to represent, or a chemical symbol to represent that particular element, an atomic number as shown in this particular video, but also a mass number. Atomic number would give the number of protons and electrons, the mass number gives the number of protons and neutrons. So there we have a very quick introduction to the periodic table. Okay, I hope all that helps.